Hey there! So, in this lesson, we'll be learning applications of trigonometry. All it really is using our past lessons to solve problems and deciding on to which equations we use, which method to use. It's just practice problems. That's all it really is. So the best way to learn, as I always say, is to do homework questions or at least examples. So let's go through the examples. So the first example says here, the first leg of the Olympic triathlon is about 1.5 kilometers swim. What they really mean is if you get the perimeter around here, it's going to equal 1.5 kilometers. That's what they mean by leg. To set the course, which is the shape of an isosceles triangle, an isosceles triangle is where both sides equal each other. This side and this side equal each other. Um, Two buoys are placed in the water 0.6 kilometers up from the transition zone. Again, we have a diagram which makes things a lot simpler to understand. If you don't have a diagram, then you probably should draw one because that's the best way to understand these type of problems. You need to draw a diagram. To complete this leg of the race, athletes swim in the circuit from the transition zone to the first buoy, then the second buoy, and then back. What is the angle between the lines of sight from the transition zone to the buoy? So it's asking for what this angle is right here, or essentially it's at angle X. And this triangle has been redrawn, so it's a little bit easier to understand when it's labeled X, Y, and Z. And yeah, let's get to it. Let's get to the solution. And the first part is really easy. It tells you that the whole perimeter, or in this case, calling the leg, is 1.5. So essentially, you can just subtract 1.5 minus these two to give the value of x. Okay, let's do that. Let me get my pen tool. Okay, here we go. Let's get to it. So let's find x. So x, in short, we know the whole course is going to be 1.5 kilometers, right? We're going to minus 0.6 and then minus 0.6 because this 0.6 and 0.6. And that gives us 0.3 kilometers. So that first part was pretty easy. And over here, we want to find this angle. And here I can tell that, oh, actually, you know what we should do? We should put this value up here. It's always good to label your diagram so everything else becomes easier to sort of understand. 3.0 kilometers. Okay, so I can tell right away if looking at this diagram, I have this side, I have this side, and I have this side. I have all three sides, which means I can use the cosine law. So let's use the cosine law. I'm just going to write out the cosine law so you know what we're, it's always good to write the formula out so it makes you memorize it. And it's just a good idea. Like you can pop in the numbers right away if you know your stuff, but it's always a good practice to write it out. So small y plus small z minus 2, and this will be y, z, cos, and this will be capital X, right? So if you rearrange the equation, because we're looking for x, capital X, you get cos, capital X, rearrange the equation, which would be small y plus z minus x squared over 2, I'm gonna put this in brackets so it's easier to see, y and z. Okay, let's drop our numbers in. I'm gonna say over here, cos. Like you can do one more additional step, but maybe I should do this in multiple steps. Might be easier you guys to follow along. So that's why I'm doing it like this. So easier guys to see the numbers go in. So bracket 0.6 squared plus 0.6 squared minus, I maybe calculate to be 0.3 squared, the whole thing divided by 2, 0.6 and 0.6. You drop that into the calculator and you get cos x equals 0.875. And to find x, again, you do x and then you do the inverse of cos. That's how to get rid of the cos there, and I put that in brackets. It'll be 0.875 0.875, and that will give me a value of 28.955, and I believe it wants you to round it to the nearest degree. Right over here, nearest nearest degree. So I'm gonna do this, and this is sort of the approximate sort of symbol. So I'm rounding it to the 28 point. Oh wait, it should be 29. Let me just go back there to the nearest degree. There we go, 29 degrees. And you can write yourself a statement here, saying that the angle is 29 degrees. But I'm just gonna move on because you guys can write the statement. Now you should be writing a statement, but I'm gonna move on because I just want to teach the lesson. Okay, let's look at the second problem. Let me just, there we go. So example 2, set a bike course. The next leg of an Olympic triathlon is a 40-kilometer bike ride. The first two parts of the bike ride are measured as shown. After the second part, the athletes must make a sharp turn before completing a lap. How many laps of this bike must the athletes cycle to complete the leg of the triathlon? Okay, so essentially it wants to know how many laps to complete the triathlon is a 40-kilometer bike ride. So I'm thinking divide it, but you know what? It's good to find all in order for you to completely understand the problem. It's sometimes better to complete the triangle and all its angles and its sides, and then we'll see how things work out. And here is the triathlon, the course of the bike ride part. Here is redrawn in a triangle form. Everything is labeled as A, B, and C, so it makes things a lot more easier. And I can tell right away I'm using sine law. And how do I know? Because I have this angle here, sine law, and then I know it has a corresponding side right over there. So angle and side are both given. I know right away I can use sine law because I have both those pieces of information. And sine law is a very easy equation to use and just to memorize. Okay, so first thing to do, use sine law to determine the angle of A. So find what this angle is. Okay, so let's find what this, and once we have this angle, we can find angle B, and everything becomes a lot more simpler. Okay, so let's find angle. So we can use sine A over small a, and we have these two pieces of information. So we're going to say sine capital C over small c. There. And I am going to rearrange the equation to be let me see how much space I have. I don't have much space. Okay, I'm gonna try the best I can. So sine capital A, and if I rearrange the equation times this by A over 1, multiply both sides, then we end up with A, put that in brackets, sine capital C over C, put that in brackets, and we should get, well, let's drop our numbers in, which is 3.2 brackets sine 25, because it's 25 here, divided by, oops, divided by 2.2, and that gives us a value of 0.6147. 0.6147. Okay, but we're looking for A, not sine A. So sine A essentially equals 0.6147, right? To find A, we got to get rid of the sign, so we're using inverse of sine, and then 0.6147, and that gives us a value of 38 degrees. That's what A equals. So there we go. We found what A is. We can drop it in a diagram, 38 degrees. And I can tell right away, I can figure out what the angle of B is. So as determine B, we're going to use the property. Remember, every single triangle, all have to equal 180. Every triangle equals 180 when you add all the angles up. So B I'm going to use capital B. And this is often symbol means it means triangle, or I mean angle. It means angle. So 180 minus the other two angles, which is 25 degrees and 38. And that should give me a value of 117 degrees. Easy enough. So we have this angle, which is, I'm gonna put an arrow here like that, and that will be 117. So I have this angle. I don't have the side. I can figure out what the side is by using the sine law, because I have this side and I have that side. I have both sides corresponding, so I'm gonna use sine law to figure out this. Okay, so let's do that right now. I'm gonna use this equation because b is already on the numerator and it makes our life a lot simpler. We don't have to rearrange it around as much. I'm gonna use this one, the c. I can use a if I wanted to, but I would rather use c. It doesn't matter. You can use a or you can use c. You still get the same answer. There we go. We have that, and you rearrange the equation. It'll be b equals, again, how you rearrange it. You do sine b over 1 times sine b over 1. Again, I did both sides, so therefore it should equal, except this side cancels out with this side. And so basically b equals c. I put that in brackets. Sine b over sine c. And if you drop our numbers in, we have b equals 2.2 brackets sine b is 117 over brackets sine 25. And we get a number of 4.6, and everything is in kilometers because we're working in kilometers. See, these are 2 kilometers. And there we go. We have B. So now it says here, determine the number of laps the athlete must complete for 40 cycles. So the first thing we got to do is know what's the length going around. So the length going around here, let's add them all up. What's the total leg? What is the leg? The leg is, or I'm gonna say L for leg. And essentially this kind of, so 4.6 plus, what's the other two sides? 4.6, 2.2 and 3.2. Is it? 2.2, 3.2. 2.2 plus 3.2, and that gives us 10 kilometers. So it's about 10 kilometers all the way around. 4, 5, 6, 7, 8, 4, yeah, 10 kilometers. So the whole course, basically the determined number of laps Valley must complete for 40 kilometers. So essentially it's 40 kilometers a sense divided by 10 kilometers, because that's distance around the lap, right? And we end up with four laps more specifically. So you need to complete 4 laps around, or 4 laps around this, 1, 2, 3, 4, to end up with 40 kilometers in total. Okay, let's move on to the next problem. Okay, so that problem was a little bit tricky, but this problem here, um, I can tell right away. I'm looking at this diagram. It's going to be like we use SOHCAHTOA because there's a right angle right here. A right angle. Whenever you see a right angle, then you have SOHCAHTOA is available to you in addition to the cosine law and the sine law. And I think that a SOHCAHTOA is the easiest equation of all of them. So I would rather rely on SOHCAHTOA, and then that's my first go-to is SOHCAHTOA, and then my second go-to would be sine law, and then my third one, if I had no choice, then I would use the cosine law. But yeah, let's read the question first. Mika is making a new garden in the corner of her backyard. It will be against a privacy fence and a patio as shown. So this is the privacy fence, and this is the patio. Micah wants to build a fence along the front and patio side of her garden, but not along the privacy fence. What length of fencing will she need to the nearest meter? So she wants a fence along this side, and she wants a fence along this side here. She wants a fence there and there, but not there. She doesn't want anything there. So what we're gonna do is we're gonna use SOHCAHTOA to figure out what B is. So here, let me just get to that part. Okay. The question becomes, which one of SOHCAHTOA are we going to use? Are we going to use this one? Are we going to use this one? Or are we going to use this one? Well, let's look at the information that we have. We have this. This is your hypotenuse. We have an angle here, and across from the angle here, that will be your opposite, and this will be your adjacent. So we are looking for the adjacent. That's what we're looking for. So we're looking for this, and we have that, and then we have the angle. So we need an equation that has A and H in it. So let's take a look here. A and H. A and H. So we have here cos. Cos has both A and it has H. So that's the equation we're going to use. We're going to use cos, the angle, which is going to be, I'm going to use capital, here, probably capital A, because that's small a, right? The small a. So I'm going to capital A there. Or maybe just use the angle symbol. So the angle symbol there. And it's A over H. So A over H, because that's SOHCAHTOA, A over H, which essentially is B over H is 12. 12 meters, right? Let me rewrite this out so it's a little bit easier for C. So cos, and now the angle is already given to us, which is 50, equals B over 12, right? And if you want to find, basically cos is really over 1. And if you want to basically find B, use a little bit of algebra. I'm going to multiply this side by 12 and this side by 12, or more accurately 12 over 1, 12 over 1. Because 12 over 1 is the same thing as saying 12. But this 12 cancels out this 12, and then all you have is 12 cos 50 equals B, right? And so if you pop that in the calculator, we have that B equals 7.7 meters. 7.7 meters. So we can write down here B equals 7.7 meters. It's always good to label your diagram. So we have B now. So as it says, determine the length of fencing. Again, we know that we want this fencing here, this length here, and this length here. So we just add those two numbers up together. So I'm going to say length equals 7.7 meters plus, I believe it was 12 meters. 12 meters. And we should get 19.7 meters. Oops. Meters. There we go. Okay. This part here, you haven't really learned much, but it's sort of like an everyday problem. A bag of topsoil costs $1.99, or basically $2 with tax. That's with tax, and covers an area of 4 meters. How much will it cost for Mika to cover her garden with a layer of topsoil? Okay, so you just basically want to cover her entire garden with topsoil, and it tells you that one bag is about 4 meters squared. So you see the squared here? You can tell right away this is area, and it actually says area here. So what you have to do is you have to calculate, well, you have to calculate the area in a sense. But we know that the area of the garden is basically, I'm going to write the formula here so you can see. We base times height divided by 2. Listen, do we have base? Let's take a look here. We have our base here. We have our base, which we calculated earlier, 7.7. We do not have height, but we have the hypotenuse. So there's two ways you can go about this. You can go about this by using SOHCAHTOA. You can go about this a lot of ways. But you know what? I'm going to use Pythagoras theorem because this is a 90-degree angle. So I'm going to use Pythagoras theorem to solve for A. So because we need to know what the height is in order to find the area. I'm going to use Pythagoras. You don't have to use Pythagoras theorem, but I'm just using what I think is the easiest to do. So I'm going to use Pythagoras theorem. If you remember Pythagoras theorem, it's basically c squared plus a squared. Oh, that's not right. It's c squared equals a squared plus b squared. That's Pythagoras theorem. But if you had to isolate for a, you end up having well, if you isolate it, it'll be a squared minus c squared minus b squared, and then you root it, be a squared, oh, not squared, your root will be a root c squared minus b squared, and that's basically how you find that part there. I'm going to do that right away. I'm going to say a equals, actually, maybe I should put that over there. A equals root c squared minus b squared. And then basically a, in short, equals 12 squared. It's not plus, it's 12 squared minus b squared is 7.7. And that whole thing gets rooted, and we get a number of 9.2 meters, because it's in meters. Up here is working in meters. So it's meters. And now we have A, which is our height. So we have height. Oh, sorry. We have A, which is our, yeah, it's a height in a sense. So that's where we height. And then we have, but the basis is 7.7. So we have everything we need for this formula. So the base in this sense is 7.7. That's the base. The height we calculated earlier is 9.2 meters. And we should always label our diagram. So what was it, 9.2? 9.2. There, 9.2. And if you drop this in our calculator, we should get 35.4 meters squared. Meters squared. So 35.4 meters squared, good enough. So it says here, determine how many bags of soil needed for each topsoil that covers that. So each bag, so we have our area is 35.4 meters squared. That's the area of the garden itself. But each bag only covers 4 meters squared. That's each bag. So how many bags in total? Well, let's drop that in a calculator, and we should get 8.85. Oops. 8.85. Well, that's 8.85 meters squared. But you know, we can't have. Oh, let me just erase that. It's not square because these units cancel out. So it's 8.85 bags, but you can't have an 8.5 bag. So you might as well just round it up to 9 bags. Because you can't have like a little bit of a bag. You can only buy things in bags. So you always round upwards. If you have a decimal, you round upwards towards the number of bags. So it'll be 9 bags. So we have 9 bags of soil, and we know that that each bag, if you look at the cost of the bag, each bag costs 1.9, right? So what we're going to do is going to multiply the bags by the cost, because there's 8 bags. So we can say here dollars is 1.99 dollars per bag. That's per bag, right? And we're going to multiply it by 9 bags. Bags cancel out. We end up with 17.91 dollars. It's basically it costs you $17.91 17.91 to cover your entire backyard with topsoil. And sometimes people do that. They see their garden or their lawn dying, and they just cover the top with soil, and eventually after a couple days it looks really green. So that's a little gardening tip for you. And that's it for this lesson. Okay.